Hi, everybody. Welcome back to Dave's Math channel. I'm your host, David Tare, and this is my continuing feature on the Math Lovers book. And I'm up to section 4.3 of volume 1, which is on complex arithmetic. Today I'm going to talk about complex division. Anyway, let's begin. Um, last time I talked about the complex conjugate. You might wonder what it's good for. Well, it turns out that we can actually derive a formula for dividing two arbitrary complex numbers using the complex conjugate. And this involves a trick which you probably are familiar with because you probably use it in a similar way when you're trying to simplify, um, you know, fractions. So here's how it works. Suppose we want to divide two complex numbers, z1, that's the numerator, by z2, which is the denominator. And what we do is we write them out in full. Z1 is x1 plus iy1, and Z2 is x2 plus iy2. So you might wonder how you're going to do this division. Well, here's the trick. Multiply both the numerator and denominator by the complex conjugate of the denominator. So now we're going to multiply, and that's x2 minus iy2. So in the numerator, we're going to get the product x1 plus iy1 times x2 minus iy2. And I explained a couple videos ago how to multiply two arbitrary complex numbers. So we already know how to do that. And if you forgot the formula, you can use FOIL, which I kind of do here. Well, I don't show the steps actually, but you see what the numerator is. It's just x1, x2 plus y1, y2. That's the real part, and then the imaginary part is y1, x2 minus x1, y2. So the whole thing is x1, x2 plus y1, y2 plus I times y1, x2 minus x1, y2. You don't have to memorize that. You can use FOIL if you want to derive it. But what about the denominator? Well, we're multiplying x1 plus iy1 by its complex conjugate. And I think maybe I didn't emphasize this point yesterday, but it turns out that the norm of a complex number is nothing but that complex number multiplied by its complex conjugate. I think I forgot to mention this fact. This is a very useful fact. The absolute value of z quantity squared is equal to zz bar. That's a formula you guys should memorize. So what you're going to get when you do this multiplication, x2 plus iy2 times x2 minus iy2, and you can check it yourself by actually doing the arithmetic if you want. You can use FOIL again. What you'll find is the imaginary part cancels and you're just left with x2 squared plus y2 squared, which is really just a norm of z2, or if you like, the square of the absolute value of z2. So that's what you get in the denominator. This is a useful formula. The reason this is useful, the reason this is a useful trick, multiplying a number by its complex conjugate, is because that product is real. And when you simplify a complex expression, you always want the denominator to be real because you want to be able to write out the real and imaginary components of the result separately. If you like, I could have written this as x1 y1 plus x2 y2 all over x2 squared plus y2 squared. That's the real part. Plus I times the fraction y1 x2 minus x1 y2 all over x2 squared plus y2 squared. That's the imaginary part. Anyway, that's the formula. That's how you get it. And that's how you divide two complex numbers, which is probably the most complicated arithmetic operation there is involving complex numbers. Yeah, but you got to see it. It is part of arithmetic. And this is probably one of those formulas that's easier to derive than to memorize. But anyway, glad I got a chance to show it to you. That's how you divide two arbitrary complex numbers. And we do this a lot when we do arithmetic involving complex numbers, just like you do a lot of divisions involving real numbers. So anyway, that completes my video for today. Thank you for watching. Long live math, and I'll see you guys next time. Bye.